Hi class. In this lesson today, we're going to be, or in this video today, we're going to be going over lessons 5-9 and 5-10. And I would like you to please make a change to what was printed on your note guide. It's a typo. For lesson 5-9 and 5-10, it should say we're covering function operations and then composition of two functions. So can you please scratch out what it currently says on your note guide and add in those two titles, if you will. Okay, so the first part, 5-9, is short and sweet. It's basically just on how the operations of addition, subtraction, multiplication, and division, how they work with functions. Or not even how they work, but just what they look like when you combine that with a function notation. So these over here, this is what I mean when I say function notation. So what your job is as the student is to not let this notation like trip you up or trick you. When you see these parentheses right here, f plus g, and then you see parentheses x, that does not mean multiplication. It instead means you just take whatever the expression for f of x is and you just add that to the expression for g of x. Same thing if you see this notation, f minus g parentheses x. That does not mean multiplication. It means you just take the expression for f and subtract from it the expression for g. So both of these, you're basically adding or subtracting like terms from the g of x and f of x expressions. Okay, so again, you're not multiplying x to anything. This is just calling it a new function. So what this is saying is that when you add two functions together or subtract two functions together, you're creating a new function. And so that's what that notation is indicating. Like, oh, this is a new function of x. So it's like f plus g of x, not times x. Here, you're going to just multiply f and g together. And here you're just going to divide g from f. So the only thing you have to be on the lookout for when you're dividing by a function is just to make sure that there's no x's, or to restrict, I should say. Make sure to restrict any values of x that would make that function equal to 0. Okay, so we're just going to try a few examples with this. Down here I have this equation for f. It's the x squared plus 2x plus 4. And then I have this equation for g. It's negative 3x plus 2. And then all these different notations that I want you to, get familiar with. So again, this does not mean, to add or to subtract f and g and then multiply x. That is what it does not mean. What it does mean is to just take the f of x expression and from it subtract the g of x. So that's what it means. So I'm going to take the f of x expression, x squared plus 2x plus 4, and then I'm going to subtract from that the g of x expression. And that's it. That's all I'm going to do. I do need to be sure to distribute that negative. That's important because I am subtracting all of the components of g of x. So that would give me a plus 3 and a minus 2, a plus 3x and a minus 2. And I do need to combine like terms. That's always a thing. But then once I've done that, then I'm done. This expression is the result I get when I add the f and g functions together. So this is like a new function. We could call it the f plus g of x function. Oh, I'm sorry, the f minus g of x function. Just kidding. That's what this is because that's what I just did. I subtracted. Then in B, it's wanting us to find a different function. It's wanting us to find when I add the g together with the f function. And the order of addition doesn't matter. The order of subtraction is important. So you always want to make sure to write whatever function comes after the subtraction. That one I always put in parentheses to remind myself to distribute the negative. When it's plus, though, it really doesn't matter what order you write these in or if you use parentheses or not. I'll go ahead and follow the order given just because I think it's helpful to do that. But it really doesn't matter when you're adding. So I just take the g of x expression right here, and then I just add that to the f of x expression over here. And then I just combine like terms. So I've got a negative 3x and a 2x, and then a plus 2 and a plus 4. So I've got x squared minus x plus 6. And so that would be what I get when I add g and f. So this would be my g plus f of x function. And then that's my answer. It's just the result of adding these expressions. When you're asked to multiply functions, you do need to multiply their pieces together. So this does mean, actually let me use a different color. This does mean that I'm going to take f of x and then multiply that to g of x. So I am going to have to FOIL because f of x has 3 terms, and then I need to multiply that together with g of x, which has 2 terms. So that does require FOILing. And when I watch you guys work at the whiteboards, I've noticed some of you like to use these boxes to organize that multiplication, which I really like. Hold on, let me move this down a little bit so I can write above it. What I like about it is because, like, for example, in this case, I have 3 terms in f of x. So that's going to give me, and then I'm multiplying that to 2 terms. So that's going to give me 6 total products before I combine like terms. So like this term and this term are going to end up getting their own rows. And then these would go up here. And it's just a nice way to keep track of all 6 products that happen when you FOIL everything. And then in each box, you just put the product of each of the items. So this would be like negative 3x cubed, because I do negative 3x times x squared. That times that would be negative 6x squared, and so on and so forth. And then, so these are all the 6 terms I would get if I just went through and FOILed, like negative 3x times x squared, negative 3x times 2x, negative 3x times 4. That was like all these. And then if I did 2 times x squared, 2 times 2x, and 2 times 4, that was all these. So it just kind of keeps track of all that in this nice, compact little setup. And then the like terms usually end up on the diagonals, which I love. So anyways, you can start combining all your like terms. So we have x squared like terms and x like terms that we can combine. So the product would be a negative 3x cubed, a negative 4x squared, a negative 8x, and then a positive 8. And then that collection of terms is the product of f of x and g of x. So this would be my f times g of x function. And it makes sense that my highest power is 3 because I had a quadratic times a linear. And so it's going to end up giving me a cubic. Okay, and then in the very last one, it just wants us to take these f and g equations, and it wants us to put f in the numerator and g in the denominator. So my f of x function, that's my x squared plus 2x plus 4. My g of x function, that's my negative 3x plus 2. And I can't cancel anything because there's no common factors. So these are both already in their simplest form, so I'm just done. I would want to make sure, though, that I recognize that x can't be 2/3. That would make my denominator 0, but other than that, I can't simplify further, so I just leave it. And also, I forgot to write, because when you have f over g of x, that's basically saying take your f of x function, put it in the numerator over your g of x function. And then this is just saying, like, don't let f of x be 0. So restrict any x value that would make that happen. And so here's our final answer. So that's it for 5-9. That's pretty much all you need to know or be able to do for 5-9. It's just a matter of recognizing this notation, not confusing it with multiplication, and just knowing like what this means. Okay, now we're going to move on to 5-10. So 5-10 is on composition of functions, which is a little bit more involved than just simply adding, subtracting, multiplying, or dividing. So you'll notice here this notation with like an open circle, right? So this is, so g open circle f of x, that's not the same thing as g dot f of x. G dot f of x, that means multiply. And we just multiplied. This means compose. So I'm just going to take a minute. I'm going to move away from the outline for just a moment, or from the note guide, and we're just going to talk a little bit about what it means to compose. Okay, so suppose I said that my g of x function is equal to 2x plus 8, just something like that. If I asked you to find g of 2, I want you to think, like, what does that mean? Hopefully you're realizing that that means, oh, I have to take 2 and plug that in for x and then evaluate. And then I get 4 plus 8, which is 12. And then I'd say, oh, g of 2 equals 12, because it's the result I get when I plug in 2 for x. And that's what g of 2 means, right? The 2 that I put in the parentheses where the x gets plugged in to the expression in g of x where the x used to be. Okay, so similarly, I want you to think about, what would you do if I asked you to evaluate g of a plus 1? And hopefully you're recognizing, well, I would just take a plus 1, this part, plug it in the g function where x used to be. Just like we did earlier when there was a 2. I put 2 in the same place where x is in the g of x function. And then I would evaluate that. So I'd get 2a plus 2 plus 8, and then that would be 2a plus 10. And this expression would be what g of a plus 1 equals. It equals 2a plus 10. Okay, so then I want you to think further. All right, what if I asked you to find g of f of x? Well, I hope you're recognizing that when it was a plus 1 inside the parentheses, I subbed a plus 1 in the same place in g of x where the x is. When it was 2 in the parentheses, I put 2 in the same place in the g expression where the x is. So I hope you're recognizing that if it's g with an f of x inside, I would just take f of x and put it in the x spot, or where the x is in the g of x equation. Now suppose I said, okay, so f of x is equal to 3x minus 2. So then I hope that you would recognize that that means, so if it's g of f of x in the parentheses, f of x being 3x minus 2, that's basically saying, what's g of 3x minus 2? Well, g of 3x minus 2 is what you get when you take 3x minus 2 and plug it in the x spot in the g function. So 2 times 3x minus 2 plus 8. Because in the g function, it was 2x plus 8. And so what we're doing is we're just replacing whatever's in the parentheses, or we're replacing x in the g of x function with whatever's in the parentheses. So if f of x is in the parentheses, and if we know what f of x is, we're basically putting that expression in place of x, where the x normally goes in the g of x expression, and then simplifying from there. So in this case, that would be 6x plus 4. That would be the result of g of f of x. Now, the other notation that means the same as this is GOF, g of f of x. So that's how you would read this out loud. You would read this as g of f of x. And it means you're going to take x and plug it into f, which was already done here. 3x minus 2, that is f of x. Then you're going to take that and plug it into g. That was the part where we did 2 times 3x minus 2 plus 8. We were evaluating what the g equation would be if the x in the g equation was taken out and replaced with the f of x expression. So this means g evaluated at f, which was evaluated at x. Okay, let's go to the note guide and go back to this notation. So here they kind of show again, you have your open circle notation, which means like g of f of x. That means the same thing as plug f of x into g of x. And then if you're evaluating, you would evaluate the inside function first, right? This would go first, and then you take that and use it as your input for G. So then this would get plugged into G. So I always like to say it as like start from the right and work your way left, or start from the inside and work your way out. So X is like the most inside thing. So if that's a number, you start with that, you plug that into F, and then you plug that result into G. Like that. So I'm going to do an example. I'm going to do a couple examples, one with a number and one without, with just different equations. So let's let f of x be 7x minus 5. And let's let g of x be x squared plus 2x minus 1. Okay, so for one example, let's suppose you were being asked to find f of g of 3. So notice I changed the order here because I want you to understand order matters. So this means the same thing as f of g of 3. So it's saying take 3, that's the x value, so that's what that means. That means x is 3. You take that and you plug it into g. So you plug 3 into g. And then you take the result of that and plug into f. Plug result, sorry, into f. It got squeezed in. So this is more of a visual of what that's happening. So 3 is going into g. So let's work that out. So g of 3 would be what I get when I just plug 3 into the equation where the x's are. So it's 3 squared plus 2 times 3 minus 1. So that would be 9 plus 6 minus 1. So that would be 14. Okay, so that's g of 3. So then this is saying to take the result of that. So take that 14, and then now that becomes the input of f. And then you take that and you plug it into f. So this is the result of g of 3. Okay, so now I take that and go over to this f of x function over here. So then f of 14, that's just 7 times 14, and then minus 5. So that would be 98 minus 5, which is 93. So f of g of 3 is equal to 93. And that's how composition works when there's numbers involved. And again, this does not mean multiplication. So that's another thing I want you to kind of indicate to yourself. This does not mean multiplication. It means you're plugging in. You're taking 3 and plugging into g. You're taking the result of that and plugging it into f. You're not multiplying. Okay, another example with these same equations would be if I wanted to find, let's say, g, so this is example 2, g of f of x. What does g of f of x? So maybe I will write it this way first. So suppose you were asked to find goff. And remember, this means g of f of x. So it doesn't mean g times f. It doesn't mean g of f times x. It means g of f of x. So it means take your f of x equation and literally plug it into g. So we're going to plug f of x into g. And it goes wherever the x used to be in the g of x equation. So the g of x equation says to take x and then square it. And then to add 2 times that same x, and then to subtract 1. So what we're doing is we're replacing that. What used to be x is now f of x. So we're plugging this expression, this 7x minus 5. This is basically saying find g of 7x minus 5. So I would need to do 7x minus 5 squared plus 2 times 7x minus 5, and then minus 1. Okay, so I'm gonna have to do some foiling work, whoops, off to the side so I can squeeze my answer in. So excuse me while I kind of go off to the side here. So 7x minus 5 squared, that means you need to FOIL this out. You need to write it out twice and FOIL it. So you get that, 49x squared. You would have negative 35x, another negative 35x, and then a plus 25. So you would have a 49x squared, a negative 70x, and then a plus 25. So that's just the first part of this. This would be 49x squared minus 70x plus 25. Meanwhile, you'd still have to distribute the 2 to the 7x minus 5 from this part of the equation. So that's 14x minus 10, and then you'd have to subtract 1. So when all is said and done with this example, we would end up with, I'll write it down here, 49x squared. I would have to add my negative 70 and my positive 14. So that would be negative 56x. And then I would add 25 and negative 11. So that would be plus 14. And that right there would be my GOF, my G of f of x function, or you could write it this way as well. But this is the new equation that results when I take the f of x function and plug it into the g of x function. I get a whole brand new function. So lastly, I want to kind of go through how this might work if all you're given is like a graph or a table of two functions. So I'm just gonna come up with some points here. This will be my f of x graph. And let's see. So this will be negative 4, and then this is at 3 and 5, and then we'll make this at 2, 4, and 6. Okay, and then we'll do a g of x function that maybe starts here and then goes down to there, and then maybe up to here, and then continues going up to there, and then goes down. So we'll say this is negative 1, negative 2, negative 3, negative 4. Okay, sorry, I had to make up some generic functions. Okay, so this will be my f of x, and then this will be my g of x. So I wanted to show you how you would do something like, let's try one. Let's see if it even works. I don't even know. Let's do f of g of 3. Let's just see if we're able to read this on our graph. Okay, so f of g of 3 would mean that you're supposed to take 3 and, quote, plug it into g. But we don't have an equation to plug into, so what you would do instead is you would evaluate the y coordinate from the graph. So you would go over to where x is 3 on your x-axis, and you would go to the g of x function, which is right here. So I'm going to say it's negative 1, just based on my sketch here. I'm going to say g of 3 is negative 1. So we would kind of recognize that just from the graph, and then I would have to take this result and plug it into f of x. So then I would have to do f of the result of g of 3. So to do that, I'd have to go over to where negative 1 is on the x-axis. I'll do this in orange. So that's like right here. And then I have to go up to the f of x function and decide what f of x is at negative 1. Let's just say it's 5. Let's just say those go together for the sake of this. So that would be my answer. So then that would mean that f of g of 3 is 5, because when I evaluated g of 3, which was over here, I got negative 1. Well, that y value of negative 1 became my input for f. I took the result of g of 3, -1, and then plug that into f. So what I did was I evaluated the y coordinate on the f of x graph when x was -1, and I got 5. So f of g of 3 is 5. Let's see if I can do another one without making the numbers get too weird. So let's say I had g of f of 2, let's say. Oh wait, no, that's kind of boring because we kind of already looked at that. Let's do g of f of 6. Okay, so this is saying you start with 6, you plug that into f. So start with 6 means x is 6, and you go to the f graph and you go, okay, it looks like f of x is, let's just say it's 3. Let's just say f of 6 is 3. So then that's the result, if you will, of f of 6. So then I have to take that result and plug that into g. So now I have to do g of 3. So now this 3, that was a y value, now I have to go to the x-axis where x is 3 and then plug that into the g function. And okay, so I ended up with -1 again, but that's okay. And I get -1. So when I go to 3 on the x-axis, which is right here, and I look at the y value on the g graph at x, I get -1. So g of 3 is -1. We had used that one earlier. And so this would be my, so then I would say that g of f of 6 is equal to -1 because f of 6 is 3 and g of 3 is -1. So those are just some examples of composition of functions. You have a ton of practice from the textbook, so I would like you to work on that right now in class so that you can work together, ask questions of each other, and then I will be back on Monday for you to ask me questions as well. We're going to do a check-in quiz on Monday, so that'll be a good time to kind of check in, see where we're at, and ask questions. And I'll see you then. Bye.